Chaud-Lançon. Excuse me for the noise around me. I don't know if you can hear me well.
We can hear you,
okay?
yeah.
Okay. Donc, I'm the Deputy Chief Information Officer of the City of Nice. And I'm working on several projects, of course, and especially on a big one, which is an hypervisor for security and safety in the city. And in this domain, we need to improve new technologies, new innovation solutions based, for instance, on artificial intelligence. And we are thinking about this, what kind of help we can have with this kind of algorithms, in fact. So that's why we have this meeting today.
I see.
Thanks, Anel. So the goal of this audition is really to benefit from your expertise in generative AI, Brandon. You will also tell us more about the company you have co-founded, Archetype AI. It's also echoing the previous auditions we did with previous experts on better understanding talk-to-data models. So how we can use natural language, how you are doing with your company to interact with AI and urban information. But maybe to start, could you maybe start by introducing ourselves and providing a brief introduction to your company?
Yeah, absolutely. Thank you. Should I use videos as well, or just keep it with voice face-to-face like this?
Maybe now it can be only face to voice, and then if you have video, we can have them for the next questions. Thank you.
That's good. I'll send a sharing request though, so that we can have it ready to go when it's time. Great. So yeah, I'm the COO and co-founder of Archetype. My co-founders and I worked at Google for almost a decade on AI for sensors, and so we built and shipped a variety of features, from face unlock for Android to car crash detection for Pixel smartphones, to on-device translation, to radar and sleep tracking for phone and smart home devices. And so our team is world-class when it comes to AI for sensors. And all that experience that we had working together inspired this new company, which is about taking the latest techniques in AI and adapting them to understand sensor data. So we are a foundation model company, and we're a bit like an OpenAI in that we are building one large model that can do many, many tasks, but we're different in that we're like an OpenAI for the physical world, because our model is built specifically to understand the world through sensor data. Those sensors could be camera feeds, they could be LiDARs, they could be radars to preserve privacy, they could be time series sensors like humidity and temperature and vibration. And so we built a model that can take all of these different sensor ways of understanding the world and fuse it with natural language. And so it's a model that can understand the world, that people can interact with language, and people can use to solve real world problems. We've built the first version of this model now, and we have it in pilots across the construction industry, to the smart home industry, to the automotive industry. We are proving out that this model is indeed able to generalize across many tasks, and as a foundation model, be used by customers to rapidly build their own custom solutions, taking advantage of their unique proprietary data.
Thank you.
Thanks, Brandon. Would it be possible to have a demonstration and maybe also some case studies of what you just presented?
Yeah, maybe I'll show 2 examples that will show some range that are relevant specifically to smart city scenarios. So let me turn on my screen share. Great, you can see my slides now. So this here is an illustration of the model and how we are mapping these different kinds of sensor data into one mathematical space with natural language. And so this is what makes it possible to talk to the data, but also for the data to talk back. And thus this model to serve as this translator from sensor signals to meaning especially where you have many signals. For example, in Nice, you surely have hundreds or thousands of cameras. Today, you might have solutions that look camera by camera, but you have more video feeds than people could ever watch, and you want to be able to reason across those different feeds. For example, when a vehicle moves from one feed to the next feed. And so this ability to take multiple sensors, put them into one model, and have that model explain to you across the sensors, that's the unique thing that we are trying to do. But let me now show a couple of simple examples. This is an example of using a fixed camera to look at this intersection. And so you can see a picture from that camera feed. And to keep these examples simple, these will all have a single camera, but we do have customers, for example, who have 27 cameras. But you can see here in this intersection, what this screen is showing was the ability for the AI to observe it and to count what was coming through it. But because you can talk to it, you can also be able to ask it questions. And so on the right side of the screen here is an example of asking the question, how many cars went east? And this is really interesting as a question because if you look at the picture, the two sides are different. One way, which happens to be east, has 2 lanes. The other way has 1 lane, but the model can understand that, and the model can generate charts. And so it's able to not only have you talk to it, but it's able to create a data visualization to respond to your specific question. And in this case, to plot the 2 lanes separately.
Just
and so,
Brandon, one question, because we had a presentation from another expert a few days ago. So he presented a talk to data model, but here the goal was to access to existing data. In your case, we are like when we are doing a request, it's creating new data based on our request. It wasn't, or was it already there, the data we are?
So what was already there is what the camera had observed. But the answer to the question and the chart was not there. That was assembled in response to the question when you asked the question.
Okay. Okay.
Excuse me, to understand the schema on the right, that means is the percentage on the vertical.
The vertical in this case was a cumulative count.
Cumulative count?
Yes.
What does it mean, cumulative count? Excuse me.
Oh, sorry. So over time, the total. So from left to right, there were approximately 85 cars that went in the green lane east, right lane.
Thank you.
Now here's a video example. This time it isn't vehicle traffic, it's pedestrian traffic. And it is a camera on a drone. So this is for a recent event where we had a drone fly up, and I gave a demo at a conference inside this building. And the people that were crossing the bridge were the people headed to that conference. And so here's a video recording of being able to ask a mix of real-time and backward-looking questions. So here's a question like, is anyone on the bridge right now? And the answer is 3. And you can see in the bridge, there's some people being boxed and tracked. You can ask a question like, when were the most people on the bridge? And it can give you that number 9 at 7:32. But you can also ask about the other areas. Is anyone on the rooftop? No. Is anyone on the tracks? No. But because our model can combine many kind of concepts, you can also go deeper. So you can, for example, see if it understands why it's risky to be on those tracks. And it explains it's risky because there's a risk of collision. But we can also ask a factuality question like, how many chickens have crossed the road? And the model does not hallucinate. It says there are no chickens because it's grounded on that base sensor data. So these are examples of having a camera feed in a place and being able to query these trends over time. One more example to contrast is this app that one of our developer customers has built. This app is for navigation and maps. And what it does is it turns your phone into a dash camera so that as you are driving, your AI is observing the world. And now when it sees a road hazard like a car crash or construction or an emergency vehicle, what it does is it combines that visual information with the location data, and it uses that to generate a pin. And it puts these pins on a shared navigational map. So now every driver makes all the other drivers more aware because everyone is aware of what everyone sees. And this is fully automatic from the camera to the map. There's no need for a person to have to input this. So now this is for consumer drivers. But if you think about a city, you have buses, you have city vehicles, you have all these moving vehicles that could be sensor platforms to take these passive sensors and ambiently and continuously be building these real-time maps. And these could include things like road hazards, but they also could include things like what are the conditions of urban maintenance? Here was an example of a thing that we did in Delhi, where likewise we had the cars driving around, but at the end of the day, we could ask it to summarize where was there road damage, and the model could output this heat map of where it saw the asphalt missing. And so in this way, you can again have your own sensors on vehicles, your fixed sensors, put all their data together to build a map like this to help you spatially understand real-time conditions.
Sounds great. Thanks, Brandon. Lionel, do you have already some questions at this stage?
I have many questions, in fact. I don't know. The first thing, it's for me, it's a little bit impressive. Your technology, it's some kind of mystery. When you at the beginning, you said you can mix the data flows and the video flows from several cameras to construct a unique view. I cannot imagine what can we have of information based on that, and what kind of usage we can have, for instance, about this global view. The first thing, in this we have 4,000 CCTV cameras, in fact. So it's an important volume of cameras, but it's not a continuous view. In fact, in the city, it's a sports views, and I don't know what kind of information we can have if we mix all of these flows together. That's the first question I have. And on the last example you mentioned, the question is, you just storing the video flows from a smartphone, for instance, and when you analyze this information, you can create this kind of map with road damages, and it's only based on videos.
Let me answer the second question first, and then I'll come back to the first question. So on the second question, that use case is a real-time use case. So
it's all real time. Okay.
Yeah. So as the video comes through, that pin is on the map within a couple seconds.
You analyze in real time a damage on the road, and we put a spot on the statistic information from several vehicles, and from
right. Yes.
Okay.
Now, what we do as a company is we provide this model and tools to use this model to customers. And so we ultimately depend on what they build. And that company involved in that mapping application, they have chosen so far to just use video. But we have discussions about how they could use things beyond video. One example of that is that your phone, of course, has a motion sensor. Mm-hmm. And so if I was looking for road damage, what if I could combine exactly what I saw with what I felt? And there's of course many other ways you can combine sensors, but that's a simple example. And so with that, you can understand like, yes, I saw a pothole. Was it deep? Was it big rocks? Was it small rocks? And so on and so forth.
And you could mix between kind of information, video flows, and this kind of information from sensors on the phone.
Right. So this to us is the single most important thing that our model is uniquely able to do, is that it's able to mix many different kinds of data. And that's very important because it lets us assemble an understanding of the world that goes beyond any of today's models that can only work with one kind of signal.
Mm-hmm. Okay, thank you for that. And what kind of usage of a global video view with many cameras? As you have a
Yeah, a quick check. So I want to show one of the pilots, but there, this call is recorded, but this one's not going to be publicly posted, right?
No. It's not going to be published. It's recorded for the exploratory mission.
Cool. So let me talk about that customer, Lionel, who is using those 27 cameras. So this is an example of one of their job sites where we have this pilot. And now, as you can see, this camera view is very realistic, let's say, because the camera isn't very sharp. It's a bit blurry. The camera is wet. The lights are flashing. It's nighttime. Very often, too, by the way, there are spiders that live on the cameras, and so they are blocking part of the view. And so you have very, very realistic cameras, let's say. But two, you also have a very unique construction site. They are doing a canal diversion to reduce flooding. And so they have, as you can see here, an excavator on a barge, and there's tugboats who are moving it to and fro. What they are testing our model for is that they want to be able to measure the productivity so that they can compare the actual work that was done to the planned work to help them hold their subcontractors more accountable to reduce waste, because their single biggest cost is waste. So how can we help? How we can help is that number one, this is a very unique job site. So with our model, they can fine tune it. They can train it with a little bit of data, and it can become a specialist in this kind of construction. Whereas other computer vision models will have trouble adapting to these tasks. Number two, those computer vision models aren't very robust to how difficult this camera is. And then three, this job site is kilometers long. And so our model is able to reason across all those different cameras. So what they provided us was 4 petabytes of data, a massive amount of data from those 27 cameras over 4 years, plus the ongoing feeds. And what they wanted, it was ultimately quite simple, but difficult to do, is they wanted a Gantt chart of how the time was spent. And so with us, they built a tool where they can pick a task like excavation from a barge. They can pick a range of dates, and for any given date, they can get a simple chart of the time spent doing this task. And they wanted this chart because their management wants this chart. And today a human has to make this. But now the model can go from video to chart to fit how their business works. But they can go further because with this new kind of chart, they can go to the specific moment and they can see what was happening. And they can understand what caused the deviation to happen. Was there a miscommunication? Was the wrong thing delivered? Were the tides too high? And
it's
so
new sort of timeline, in fact.
yes. And so for them, this solves one problem, which is that they can now digest more video than they could handle. They can get to the specific moment for an expert to look at. And the work we're doing now is to learn from those experts. So for example, if the expert here said there was a delay because the tide was high, we are trying to have our AI learn from that so that in the future, the AI can be first and be able to recommend, we think the tide was high. And so it's this kind of continuous learning that becomes possible with these new models.
Okay, thank you very much. It's very interesting. And I have a last question. When you on the demonstration on the bridge with people and chickens.
The no chickens, very importantly. Yes.
No chicken, without chicken. In fact, you talk about the railways and things like that. And my question is, how you train the model to know where is the rail, sorry, the train race, where is the buses, and I think you have a specific training program to be able to analyze in this image this kind of information. Before you have to have a long training period.
Right. So the reason we could build that drone demo in 2 hours the morning of was because we have this pre-built model, and we've trained it on lots of things about the world. And how we think of that as a tool for developers, for folks like yourselves, is that before, you had to make your own model from scratch, or you had to buy someone else's model that wasn't customized. What we can do is that we have pre-built this model. Maybe out of the box, it can do the job, or it can do the job, say, to 80%. But that last 20%, you can teach it from your data. So here's one example. This shouldn't be the case, but let's say we we had made a mistake and we only trained it on cars from North America. And so it's never seen a Peugeot. It's never seen a thin license plate because the American ones are a bit more of a square. And so what we could do is, if we're going to deploy it in Nice, fine tune it on your local vehicles, your local how your buses look. If we went to the UK, they drive on the different side. And so we'd want to fine tune it to learn like the same rules, they still apply, but flip the road. And so it's that kind of like tailored customization that we can do at lower cost and faster because we have a pre-built model.
Okay, very interesting. Thank you. That's okay for me there.
So, Brandon, I also have maybe a question to elaborate on Lionel's question. In a simplistic way of saying it, you have one big foundation model that is potentially having all different AIs like computer vision, NLP. It's really okay. Just to be sure that to frame it, okay.
And then I would just add to, because I imagine this is one of your future questions. Actually, I think it's in the sheet anyway, so I'll go ahead and say it. If you were to build a custom model, there's our model. How we think about it is that we then fork the model and it becomes the Nice model. And that model is exclusive to you. Your data remains private. And we are developing the infrastructure so that if you had to, you could run that model on your infrastructure in data centers within France. So if you have sovereign requirements or data control requirements, we are building our model to be compatible with those.
Okay, so you need very efficient computing platform, I think. No, very.
We think it is. We think it can be a lot more efficient, but that is the work in progress.
Okay.
And Brandon, could you tell us more about this model? I mean, what is it? Is it LLM? What is it at the end?
It's the same basis as an LLM, which is a transformer model. What an LLM does is, it in effect converts words to math. That math then makes the words computable. So it does some computation on the patterns of words, and then it converts the output back to words. And so what we're doing in effect is that we have built ways to take this other kind of data from cameras, from temperature sensors, from vibration sensors, and likewise convert that into the same math as words. So we can compute them all together, and then we can translate back to words or back to charts to help humans be able to understand it.
Thank you, Brandon. And next question, like, are there already some cities and municipalities currently using Archetype AI in their infrastructures? And if so, could you provide examples of those use cases?
We have some discussions. We might be making some RFP proposals in the near future, but we do not yet. We are at the, you know.
I think you will.
Excuse me, an emergency. I'm sorry.
No, should I repeat the question, Lionel, or did you?
Please, can you repeat the question?
I was asking to Brandon if there is already municipalities or currently using Archetype AI.
There are not yet. We've have some discussions ongoing, mostly around traffic safety and monitoring of public infrastructure. There might be some proposals that we submit soon. But overall, we are still at a pilot stage and validating that the technology works at large scale for enterprises first.
Okay.
I will add, though, that it is our company's mission to help solve the world's most complex problems, especially to solve real-life problems. And so we think cities as a system are a very good goal for us to work toward. And we're very glad to be talking to cities like yourselves that are more interested than others to pioneer and trial new kinds of technologies.
And
okay.
Sorry, you wanted to say something? Or?
No. I'm listening to you.
Next question, Brandon, maybe more regarding the technical foundation of Archetype AI. So let's say the metropolis of Nice would like to use your solution in a quite operational way. Like, how does Archetype AI would integrate with existing urban sensors from the metropolis of Nice?
So our platform is built to be an API-based platform. So the first step would be to understand how we could connect via API to your sensor feeds. Maybe you have a camera vendor and they have an API that we could integrate with. Or maybe you are putting all of your data from a sensor into Snowflake or into Amazon, in which case we would connect our API to where that data is being stored, so that the model would be able to access it. And the next thing is, okay, if the API that goes into the model, the API of the data and the query, if that works out, then the next question is, what's the API back from the model of the model's responses? And that again could be the text, could be the charts, could be visualizations. We don't build verticalized software. And so that API should connect to some other software. Maybe you or an SI wants to build new software, or maybe you already have a smart city management tool. Maybe you already have a dashboard in like a control room. And so we could have the outputs of Newton via API feed into that software if that software was able to support it.
Okay. Excuse me, I have a question. When you talk about API, it means that you can collect data from data sources and on those systems, but can you also make have command and control through this API to these systems to change the angle on the cameras and things like that?
Yes. Our work in auto, for example, with some car companies is exactly that. How do you automatically control the car in response to things? And so, yes, that's one kind of output we could have from the API. Overall, we meet a lot of customers, and you probably already have too much software. We don't want to sell you additional software. We want to be able to add more smarts to your current interfaces, your current software, your current way of working.
Yes, and the second question I have, when you talk about API and you talk about model. In fact, we urbanization we have for the smart city platform is to have in the middle a data platform with data model to be independent from any vendor, from the different equipment we have for temperature and things like that. So we, for the data, not for the video flows, is a little bit different due to the volume and unstructured data we have on this kind of domain. But for other data from sensors, we are trying to have an open standard, which is FireWare, to store all the data in a data model standardized in order to be able to mix the sensor from different domain, environment, traffic, and things like that. And my question is on your approach, we are able to plug your solution on this kind of approach and to have a benefit of what we made in terms of urbanization of the data.
That kind of an approach should make it much easier and faster to do an integration. And how you can think about it maybe is that today you have this data layer, and then you have the application layer.
Yeah, exactly.
The model that
sensor layer
platform, well, yeah, essentially that's the sensor data and then the application. You could think about our platform as it goes between the data and the application. So it goes from data, then it goes to AI that processes the data, and then the output and the interaction is displayed for a human to interact with, or it sends that command and control back to the sensors, back to the traffic lights, and so on.
Okay. Thank you.
I have maybe another question to elaborate on Lionel's remarks. Is it possible to run your program locally? I mean, for cybersecurity reasons, or for different reasons, like considering metropolis might want to keep kind of sovereignty. Is it possible to run your solution locally?
So we've designed our model to be resizable based on what the use case is. If it depends on your definition of local. If you had one, maybe two cameras, you could use a Jetson box from NVIDIA that's like this big, very, very small, very, very local. But you mentioned having, I think, 4,000 cameras. And so you're still going to need a pretty big data center or server racks. But our model, our platform could be moved to your data center. Maybe it's one that the city owns through various means, or maybe it's one that you rent from Amazon or from Microsoft, but it has certain security requirements and we aren't able to access it. So that's the kind of thing we can do. We can move our model to run on your infrastructure, and we can make it as small as possible to be efficient while still doing the task. But for a thing as big as a city, if you want to do it all in one model, it's not going to be that small.
To be sure to well understand what you say, if we want to have on-premise, our own infrastructure to support your system, we need to have a powerful one to address all the sensors and camera we have. It's in evidence. And we have our own data centers. We have 2 and 3 data centers in the city. Because of sovereignty issues, we need to have this information and data on privacy rules in France and the EU very hard. In fact, so we have to respect these rules, and that's why we have many information in our data centers. It's an obligation for us, but it's not really a question. In fact, it's just to imagine the situation. If we want to have a very the benefit of your systems, and we need to have specific servers and storage platform to store your data from. Excuse me. Another way, we have a big data platform today. but we have also the data flows and the video flows. I understand that you create a model from all this data, so you replicate the data in one way, if I understand well, or you will just make links to the real data. When you show the experience on the platform, for each platform, the data you have, it was a duplication, a copy of data sources, or it's just links to the data. I don't know. It's clear my question.
Right. If the use case involves making historical queries, like for example, on this day 3 years ago, how much of the construction work was done? What our platform does to make that a very fast and efficient query is that we process all that data in advance to produce different kinds of like processed summaries. And so then we save the summaries, and then those can be computed when there is a backward-looking question.
Okay.
If
So
you had a different task, which is
level, so sorry, two level
right.
of data. Okay.
If you had a different task that was like, tell me when the water level in the river is over 1.5 meters, then that isn't a historical task. We're just going to monitor for that level and send you an alert with a timestamp when that happens. Maybe you want to save those alerts, and that requires some kind of a storage, but it is a different kind of system. And our model lets you build both those kinds of systems.
Okay, thank you.
Maybe a last question on this, Brandon, also kind of spontaneous question. Let's say you are working with an organization, a metropolis that have safety restriction and that need to be very strict on data governance, on data sovereignty. What would you recommend to work with them? What would you do to take into consideration those constraints in a way?
I mean, it sounds like the Metropolitan of Nice is pretty far ahead in that you have your own data centers, you have a data layer, you have your own compute. What I think you should begin to consider for the future is that if you want to run AI models in a sovereign way, that compute is going to require the GPUs to do the inference. And if you haven't before, you might want to begin adding that GPU capacity because regular CPU style sort of compute isn't going to be able to very efficiently run these kinds of workloads.
And NVIDIA is your friend.
NVIDIA needs to like us, yes. You have to like NVIDIA. But one nuance there is that there's GPUs for inference when you're going to run a model, and there's GPUs for training when you're going to make a model, or in our case, when you're going to customize a model. The GPUs needed for training, those are a lot bigger and a lot more expensive. The GPUs for inference can be a lot less. And so a key consideration for you is if there's going to be training, does it make sense for you to buy that training capacity and do it on your infrastructure, or should the training be on someone else's infrastructure like ours or with an Amazon, and then only after it's trained, then you bring it in and you just do the inference on your infrastructure?
Yes, I agree with that. But when you said before you have 80% of the model which is trained for for all.
That was a hypothetical example of the model maybe is pretty good, but it isn't good enough. And so you want to make it better to be good enough.
Yes, but my question is the 20 when you said 20% and 80% was trained for all the scenarios, but the 20 last percent needs to be trained on site. I understood that it's the training phase. You can make externally if you catch the information from a local site. We don't need to have a training capability on our own. We can externalize this function. Okay. If it's very expensive in terms of cost of this kind of systems, but also in energy. Powerful.
Yes.
Thanks, Brendan. So maybe we can now move forward to the third part of the meeting, talking about risks and issue management. You precised earlier that you found a way to not hallucinate with your AI. This is at least what we saw with the chicken example. Could you maybe share like how you managed to make your AI not hallucinating?
Yeah, I mean, I don't think I can say that we have solved hallucinations. I think I can say that the nature of the data that we work with, as far as we can tell so far, and there's much more research required, but as far as we can tell, it makes it easier to not hallucinate. And the reason why we think that is that, you know, these models fundamentally are trying to predict the most likely thing. For a large language model, it's predict the next word. For us, it's predict the next physical event. And so insofar as these models are based on objective data from reality, and insofar as these models have lots of sensor data, the model has a lot of information that should make it very easy and high probability that the right response is based on that data. If you ask it a question about which it has no data, I think it may well hallucinate. But that's why you should constrain these systems to focus on your tasks based on your data.
Okay, very clear. Thanks, Brendan. So, Lionel, do you have maybe a question, or is it good?
No, it's okay. So I have a noisy environment around me. So I'm sorry, it's not my office, you understand.
And are you able also to resonate with your generative, with your foundation model, Brandon, like saying, let's say you don't have the data we are looking for, but we're asking, let's say, our AI assistant to resonate. Is it something you can do with your foundation model?
I think to a degree, it would depend on how far outside of the training data set the question was. If you asked it, you know, to reason about, you know, the moon and the stars, it probably doesn't know a lot about that. But if you asked it to reason about, you know, is it better for traffic here if I put a stoplight or not? Maybe it knows a bit about that.
Okay, it might also depend on the data that was trained with the model. Okay. We're now moving actually to the last part of the meeting about skills and change management, and also maybe some of your recommendation, Brandon. Based on your experience, what would be your main advice for a city considering integrating a talk-to-data model like Archetype AI into its control center or urban management ecosystem?
So I think the most important thing is being prepared with your data and with your control system so that you can test things quickly. You know, there are probably many computer vision vendors you are aware of. As far as we know, we're the first company doing what we are doing, but maybe we won't be soon, and there will be other companies, or maybe you're working with us and you have a bunch of really interesting things that you want to try. When we engage with a partner, the biggest loss of time is them preparing the data. The second biggest loss of time is them preparing the contracts. And the third biggest is them preparing the application that's going to work with the model. And so you can do yourself a favor by, number one, having the data layer and some very clear ground truth data with which you can test the models. You can do yourself a favor by preparing the RFP or contracting process to be able to try tools without having to commit with them. And three, it sounds like you're also preparing yourself well if you have a city management system that makes it possible for other pieces of software to hook into it.
Thanks, Brandon. Do you observe new skills required for the use of Archetype AI from your customer? And if yes, what are they?
It takes a long time to change people's skills. And these jobs in the physical world are very different from jobs at a desk. And so our approach is more to adapt the AI to how people work. That's why in our demos you saw, for example, the ability to talk to the model is a really important component because a police officer in the street can talk to a model. Maybe they can't code. A construction worker can talk to a model. Maybe they can't be behind a bunch of screens all day. However, what I think could be good skills to have someone invest in at the city level is developing an expertise in understanding how to rate the quality of an AI system so that you can properly test and vet and understand what you're buying to make sure it is good and worth buying before spending public funds on it.
Thanks, Brandon. Very clear. And maybe last question, which is actually related to your latest answer. How would you maybe recommend to monitor actually and evaluate such AI systems?
So what's difficult, so there are lots of benchmarks for large language models. There really aren't any good benchmarks yet for AI in the physical world. And that's because the physical world has so many different kinds of tasks and different kinds of data and different kinds of systems. And so this is where it comes back to the city being prepared with its own data. As part of your data layer, you should create some data sets for testing the performance of certain tasks. And that way, even if there's no good benchmark that you can rely on because those benchmarks don't relate to your specifics, you then have your specifics and you can test for how your city works and for what your requirements are that an AI is able to perform as needed with that data set. So be thoughtful in advance about what you're going to measure, what those requirements are, and then it helps everyone, including the AI company. The more you can be clear about those requirements, and the more you can be like, here is the test that we need you to run to see if you can meet these requirements.
Perhaps you said that before, but I cannot remember. You're using what kind of LLM on your own LLM or from Gemini, from OpenAI? What kind of LLM you're using?
This is a foundation model that we have built.
You have built, okay.
It isn't an LLM insofar as it isn't just language. We call it a large behavior model, but it's the same kind of model, but built differently for more kinds of data beyond language.
Okay.
Yes, so this is a transformer, Brandon.
Right. You may have seen, for example, that if you have used ChatGPT recently, you can type to it, but you can also give it a picture and you can ask a question about the picture. And so now their models can understand language plus pictures plus also a sound. And so you can think of what we're doing takes that further in that we go beyond language, pictures, and sound to videos and to temperature and to vibration. But it's that continued trend of more and more data being compatible with these transformer-based models.
Okay.
And maybe by curiosity, like how long did it take to create your own foundation model?
So I do want to stress it's the first version of it, and I can't proudly say it's fully foundationally yet. But it's been several months of work. We're continually teaching new capabilities. And I think the whole life of the company, we're going to be continuing to climb in how general purpose and how well-rounded the model is. To date, we've really focused on the model getting good at the things our customers have been asking us for. things people haven't asked us for, we aren't so good at yet. But as soon as we have customers for those, we will make the necessary investments.
Very clear. Thanks, Brandon. Lionel, we're now at the end of the meeting. Do you have any important questions you want to ask before?
No. I ask all the questions I have, and I really thank you, Brandon, for your presentation and the information you give us. It was very interesting.
Thanks. I think you asked some great questions. I'm very impressed by how advanced you are as a city with the sensors, the data layer, the data centers. I'm not sure locally here in California we have cities that have so much sophistication. So thank you very much for sharing, and happy to talk at some point in the future if you think that there are ways that we could work together.
Okay.
Thanks,
you.
Brandon.
Thank you.
See you.
Bye.
Lionel, tu peux rester? Ouais, ok. Bon, qu'est-ce que tu en as pensé?
Excuse-moi, c'était un peu compliqué aujourd'hui. J'ai fait un peu j'avais plusieurs choses sur le feu en même temps. Donc, qu'est-ce que j'en ai pensé? Très sympathique. En tout cas, ça c'est
Arrêtez
quelqu'un.
l'enregistrement. Pardon.
Ouais, s'il te plaît.